Okay, so in last lecture, right, we have discussed about the uh, comparator design, then decoder design, and also you have written a code for 1-bit comparator and 2:4 decoder, right? Now, in this lecture, we are going to discuss about the multiplexer. Okay, so now you have clear with the basic block diagram of multiplexer. What do you mean by multiplexer? Many to one, right? Depending upon the select signal, or in many cases enable, then reset. These extra pins are also used. That is depending upon the application, but the many output that will get converted to a, sorry, many inputs that will get selected based on the select pins, and that will get reflected at the output side. That means based on the select pin, which input you have selected, that will transfer to the output side. That means it's a many to one converter, it's a multiplexer. Okay, a very simple definition. Now this is the block diagram of multiplexer. It may have n number of inputs and it have only one output, right? It has n number of inputs and it has only one output. So it is a very simple schematic of multiplexer. Now, for sake of our understanding, we will discuss 4 as to 1 multiplexer. Okay, that means we have a 4 inputs, and we are depending upon the combinations. Okay, based on that select pin, we will at a time we will choose a one input, and that will get transferred to the output. Okay, so what is truth table for the multiplexer? So as we are using the 4 inputs, how many select lines we will require? 2, right? Because 2 raised to n, so n will be the number of inputs. So if n is the 2 raised to 2 will be 4, that means we will require 2 select lines, right? Now what are the probable combinations for the select lines? As we are using the two, that is S0 and S1 2-bit select pins. So 00011011. These are the 4 probable combinations. And depending upon the combination, the respective input will get selected, and that input data will get transferred to the output side, right? That means whenever you will select proper what we can say the input based on the, or by choosing the proper combination of the select line, that respective input gain or whatever the data at that respective input pin will get transferred to the output, right? So this is a truth table for the multiplexer. So depending upon the application, you can have 4 as to 1, you can have 8 as to 1, 16 as to 1 multiplexer. Okay, what changes that you need to do? The combination of the select pins will get improved, or will get increased, right? If you use say 8 as to 1 multiplexer, so how many select pins you will require, or how many there will be a possible combinations for the select pins? 8 combinations, right? And for that you need to implement 3 select pins. Based on that S0 S1 S2 combination, the respective input will get selected and that will get transferred to the output. Okay, if you will select the say 16, okay, 16 as to 1 multiplexer, that means input you have a 16 input pins. So how many to select that particular or all 16 pin, how many probable select inputs you will require? 4. That means you require 16 plus 4 as an input and only one output. Okay, now talking about the 4 as to 1 multiplexer, how many inputs we will require? 4 inputs, that is D0, D1, D2, D3. Along with these 4 inputs, we require 2 select inputs also, right? That means 4 plus 2. That means in all, we will require 6 inputs and only one outputs, right? For a multiplexer, we require 6 inputs. Sorry, 4 as to 1 multiplexer to be specific. We require 6 inputs, that is 4 for the data and 2 for the select pins, and one output. Okay, this is what we require. Now we will discuss a very simple VHDL code for the multiplexer. Okay, now again, what is the basic structure? We must start with the library part, right? Now, first question, where we are using any arithmetical operator here in this case, in case of multiplexer, म्हणजे आपण कुठला arithmetical operation करतोय का, or comparison operation करतोय का? नाही. That's why in case of multiplexer, we haven't include that arith package. Okay, we haven't include that arith package. Okay, here only simply we have included the standard logic 1164 package. Why in case of comparator we have included that package, or even signed and unsigned package? Because there we want to use that arithmetical operator as a greater than and less than. That's why we were requiring that arith package in case of comparator. Also, that number, the number that we were comparing, that may be a signed number or unsigned number. For that purpose also, we require that unsigned package, standard logic underscore unsigned dot all. Okay, but here in case of multiplexer, we are not dealing with any arithmetical operation or any unsigned and signed number. That's why we can skip that packages, and simply we will include the basic package, that is standard logic underscore 1164 dot all. ओके, म्हणजे कुठल्या प्रोग्रामला कुठलं पॅकेज घ्यायचं हे पण तुम्हाला कळलं पाहिजे, राईट? तुम्ही जर काय अरिथमॅटिक ऑपरेशन्स करणार असाल तर येस, बाय डिफॉल्ट और मॅन्डेटरीली यू मस्ट इन्क्लूड दॅट स्टँडर्ड लॉजिक अंडरस्कोर अरिथ डॉट ऑल पॅकेज. ते गरजेचं आहे तिथं. तुमच्या प्रोग्राममध्ये सपोज एखादा साइंड अनसाइंड नंबर आहे, तर त्या केसमध्ये सुद्धा तुम्ही स्टँडर्ड लॉजिक, स्टँडर्ड अंडरस्कोर लॉजिक अंडरस्कोर अनसाइंड पॅकेज हे इन्क्लूड केलं पाहिजे, राईट? म्हणजे थोडक्यात सांगायचं तात्पर्य असं की तुमच्या प्रोग्रामची रिक्वायरमेंट काय आहे, त्याला कुठले पॅकेज लागणार आहेत, फर्स्ट यू मस्ट आयडेंटिफाय दीज, अँड देन ओनली यू कॅन प्रोसीड विथ द फर्दर प्रोग्रामिंग. पहिले तुम्हाला पॅकेजेस कुठले चूज करायचे हे प्रॉपरली अंडरस्टँड व्हायला पाहिजे, राईट? There are only means what, it is not the case that only these three packages are available. No, there are many more. The thing, the question is, you must have a clear understanding of which package you should include and which package you can skip. कुठलं पॅकेज तुम्ही इन्क्लूड केलं पाहिजे आणि कुठलं स्किप केलं तरी चालणार आहे, हे तुम्हाला प्रॉपरली कळलं पाहिजे. हे कसं करणार आहे? डिपेंडिंग अपॉन द operation logic that you are going to use. If you are using some arithmetical stuff, then you must include that arith package. If you are dealing with some signed and unsigned number, then also you must include that signed and unsigned, right? Clearly, then this is about the library part. Okay, this is the library declaration. Library IEEE, then use IEEE standard logic underscore 1164 dot all. Okay, this is the library part. Then entity declaration. Okay, here is the entity declaration part. Okay, now what you should write in an entity, or what we are normally writing in an entity? Okay, we are writing a ports, that means number of inputs and outputs required. And in some cases, if you what we can say, happen to declare some constant, then you can go for generic declaration also. But as here we are not requiring any constant, so simply we are going for the port declaration part, right? That means we are simply defining that inputs and outputs requirement to that black box, राईट? एंटिटीला माहित नसतं की आत काय आहे त्या ब्लॅक बॉक्स मध्ये. एंटिटी विल जस्ट प्ले अन रोल टू जस्ट प्रोव्हाइड इनपुट अँड टू टेक द आउटपुट्स, राईट? दॅट ब्लॅक बॉक्स इज नथिंग बट युअर आर्किटेक्चर. एंटिटीला माहित नसतं त्या ब्लॅक बॉक्स मध्ये काय. एंटिटी सिम्पली विल शो दॅट ओके these many inputs are requiring and this is what the output is, or these many are the output is, right? That we have to decide how many inputs and how many outputs that we may require. Okay, then this is about the entity. So the name for the entity given is mux4. Again, you can give any name of your choice. I have given here a mux4 name. Okay, you can give mux4 to 1, or you can give 4 mux1, anything, any of your choice. Okay, then this is the mux4 is the name of that entity. Then you have a port. Okay, then now here you have to clearly mention the inputs and outputs required. So first pin is a select pin. Okay, mode is input, data type is standard logic vector 1 down to 0. Okay, it is mandatorily because it's a 2-bit data, S0 and S1. That's why I have written here 1 down to 0, and data type will be a standard logic vector type. Okay, A is the data. How many bit of it is? 4-bit. That's why input is mode is input, data type is standard logic vector 3 down to 0. That means that indicates it's a 4-bit data. And finally, Y mode is output, and it's only a standard logic. That means only a 1 bit, because whatever the input, that will get transferred to a single or what we can say single pin only, or single terminal only, right? But whether D1, D0, D2 and D3 at a time, only one input will get reflected to the output. So there is no question of all the inputs will get reflected to the output. No, right? Depending upon your select pin combination, only one input will get reflected to the output. And this is what the multiplexer is, right? That's why Y, or you can say output, it is of only a single bit, right? Then that won't require a multiple bit. Then we will talk about the architecture. Okay, so this is what the architecture. So here also uh, you can use sequential statements. So begin, after that when else loop we have used here. Again, this is for your information. When else is a sequential statements. We are not mentioning a process statement because it is not required. You can do this with in a many ways. सी हे बघा, एक लॉजिक जे आहे ते तुम्ही अनेक प्रकारे त्याचा कोड लिहू शकता. जसं की तुम्ही सी मध्ये पण लिहिता, तसं व्हीएचडीएल मध्ये पण फॉर दिस सेम मल्टिप्लेक्सर द सेम प्रोग्राम आय कॅन राईट विथ अ केस स्टेटमेंट. The same program I can write with a if else statement. The same program I can write with some logical equations, right? Y साठीच मी एक डायरेक्ट लॉजिकल इक्वेशन सुद्धा लिहू शकतो, बरोबर आहे. Y साठीच मी एक लॉजिकल इक्वेशन सुद्धा लिहू शकतो. दॅट इज ऑल्सो अलाउड. दॅट विल बी अ डेटा फ्लो स्टाईल ऑफ मॉडेलिंग. द point that I want to tell you is the architecture, selection of architecture, selection of different statements and logic, right? That is up to the programmer. ते तुमच्यावर डिपेंड आहे की तुम्ही काय सिलेक्ट कराल. Okay, I have selected a very simple when else loop. So Y will get A0. That means Y will get A0. When it will get A0, the condition is select is equal to 0, 0. म्हणजे जेव्हा सिलेक्ट 0, 0 असेल तेव्हा Y हे A0 इनपुट Y ला असाइन होईल किंवा Y ला मिळेल. That means it will get transferred to the output. And what is Y? Y is our output. Else, if this condition fails, that means select is not 0, 0, then it will go to the next line. It will get A1 when select is 0, 1. Next combination, if select pin or select bit is a 0, 1, then Y, that means output, will get the A1 input, or A1 input will get transferred to the output, that is Y, right? This is the second case. Else, that means if this condition is also not getting satisfied, then it will go to the third statement, that is Y. See, you need not to mention Y every time. Okay, once you have mentioned simply Y, and you have to write this statement serially, that means indicates everything you are writing here before when, that is only deal with this Y. हे वाय तुम्हाला प्रत्येक लाईनला मेन्शन करायची गरज नाही. ओनली वन्स व्हेन यू आर युझिंग ओनली व्हेनेल्स लूप. ओके, जेव्हा तुम्ही व्हेनेल्स लूप वापरता तेव्हा हे वाय यू कॅन मेन्शन सिंगल टाइम. ओके, नो प्रॉब्लेम, इट इज अलाउड. Then third case will be when select inputs is 1 0, then y will get a2 input, or a2 input will get transferred to the output, that is y. And the last case, when you will select the last combination, that is 1 1, then y will get a3 as a output, or a3 input will get transferred to the y, and y is nothing but your output pin terminals, else a0, right? That means if anything doesn't matches, then by default the first, that means a0 will get assigned to the output. Okay, here you can mention a1 a2 a3 or anything, that is up to you. By default काय द्यायचं हे तुम्ही ठरवू शकता. It is not hard and fast that you must mention a0 only. Okay, no, by default you can decide any input, that is will be 0 1 2 3, any input you can decide. Okay, and behavioral, this is what the end of this architecture. Okay, so this is what simple code for 4:1 multiplexer. Okay, a very simple code for 4:1 multiplexer. In this way, in the same way, you can go for 8:1 multiplexer. What changes that you can make in the program? So here select line will be 3 down to 0, and input will be 7 down to 0, that means 8-bit input, right? Now here you have to write the 8 cases, and for 3-bit select input. This is the only change that you can make in this program, and you can write program for any n:1 multiplexer. N will be anything, that may be a 8-bit, 16-bit, 32-bit, doesn't matter. Okay, you need to modify your ports, that means inputs output, and you have to write that many combinations. If you are writing 16:1 multiplexer, here such a 16 cases will come. Okay, and this select will be a 4-bit, and here a0 to a15, 16 input, or what we can say 16 cases will come here for 16:1 multiplexer. If you are talking about 8:1 multiplexer, then here such a 8 cases will appear, a0 to a7, and here also you have to change appropriately. If you are writing code for say 8:1 multiplexer, then 2 down to 0, that means 3-bit selects will be there, and for input you have to write 7 down to 0, that is 8-bit input, and for select pin you have to write 2 down to 0, that is 3-bit input, 3-bit select pin. Okay, y will be always a 1-bit output data. Okay, so just small changes in the program, and you can write anything, or n:1 multiplexer code. Okay, now you can use this when else statement. Instead you can go for case statement also, as we have used in a decoder part. Okay, case statement पण तुम्ही इथे वापरू शकता. If else पण तुम्ही वापरू शकता. For if else, then you have to write such a 16 if else loop, right? You have to write such a 16 if else loop. Okay, so you can use if else loop, you can use case statement, you can use process statement, right? So the thing is what, how many how many commands or how many syntax that you know, then you can you will be a good coder, or you will be a good programmer. जेवढे जास्त तुम्हाला syntax logic माहित असेल, then you can write a better program in for any module, for any design, right? So this is what the simple program of 4:1 multiplexer. Okay, now in next lecture we will discuss about the demultiplexer part. Okay, and then we will move to the sequential designs, that is flip-flops, shift registers, ALU, 4-bit ALU, how to design arithmetic and logical unit with the VHDL. Very easy design. Okay, then these all parts covers in the sequential logic, because in case of D flip-flop, in case of shift registers, you require a memory बरोबर आहे की नाही, तिथं मेमरी लागते आणि म्हणूनच त्याला आपण सिक्वेन्शियल लॉजिक डिझाईन म्हणतो. राईट. हे जे आता आपण सगळे बघतोय ते कसं आहे, कॉम्बिनेशनल लॉजिक डिझाईन आहे. दॅट दॅट डोंट रिक्वायर एनी दॅट वोंट रिक्वायर एनी मेमरी. मेमरी एलिमेंट लागतोय का मल्टिप्लेक्सर मध्ये? नाही लागत. नो नीड. राईट. सो in next lecture we will discuss about the demultiplexer, right? Demultiplexer, 1 as to 4 demultiplexer, or we can go for 1 as to 8 demultiplexer, and then we will start with the VHDL code for the sequential logic design. Okay, so uh, this is what for today. uh, we will stop here. If you haven't understood anything, you can ask me right now.